Hello all, welcome to my channel. I am Ashwin Sharma and this is my first video on this channel. So in this video, we are going to see the logic we use to solve the longest common subsequence problem using dynamic programming. Suppose we are given with two strings GTCAB and GXTXAB and are asked to find the longest common subsequence between these two. We can use the dynamic programming to make this problem much easier. To find the longest common subsequence using dynamic programming, we are going to use the matrix method. So the logic we are going to use here is given in this particular code snippet. Here we compare the two strings character by character. If the character of string 1 equals character of string 2, then the entry of that particular cell is the incremental of its upper left diagonal element. Else, we compare the adjacent left column entry of that cell and the adjacent upper row entry and fill the cell with the maximum of these two values. Now let us look how do we fill the matrix. First, we fill out the first row with the first string that we are given, that is GTCAB, and the first column is filled by GXTXAB, that is the second string, and we denote the row by the letter I and the columns by letter J, and the second row and the second column is populated with zeros to start the algorithm. You can also see that the sequence starts from the third column and the third row. So the second column and the second row does not contain any character. So we fill it with zeros. Now we start by filling the matrix. So we compare the first character of first string with the first character of second string. So here we have G in the first string and G in the second string. They are common. So by using this logic, we get if input of I equals input of J, then the cell entry should be the increment of upper left diagonal element. So we increment this 0 by 1, that is 1. So next we move on to the second character of first string and compare it with the first character of second string. They both have only one character in common, that is G. So we take the maximum of the upper adjacent row and the left adjacent column. So the maximum of 0 and this 1 will be 1. Next we compare this GTC with G. So here also the characters are not common. C is not equals to G. So we take the maximum of this 1 and 0. We get 1. Again, when we compare GTCA with G, the last characters are not equal. G not equals A. So we take the maximum of this 1 and 0. Again we get 1. Similarly, for the when we compare GTCAB with G, we get 1, that is the maximum of 0 and 1. Now we move on to the next row also. Now we compare the first character G with GX of the second string. So here we have only one character in common. So we take the maximum of this 0 with this 1. So we get 1. Next we compare GX with GT. Here also the last character are not matching. So we again take the maximum of this one and this one. We get 1. Similarly, when we compare GTC with GX, the last character don't match. Hence again we go with this logic, that is the maximum of left adjacent column and top adjacent row. So again we get 1. So now again we go with GTCA and GX. Again we get the 1 as the cell entry because maximum of 1 and 1 is 1. Similarly, when we compare Gx with GTCAB, that is the whole of first string, we get 1. Next we move on to the next row. So now we compare GXT with this G. Here the last character, that is T and G, are not equal, so we take the maximum of this 0 and 1, we get 1. Now when we compare GT with GXT, that's the last character T and T are matching, so we have to take the increment of this upper left diagonal element, so this cell entry becomes 2, that is 1 plus 1 equals 2. Next we compare this GTC with the second subsequence GXT. Here the last character don't match, hence we have to take the maximum of this one and maximum this 2, so we get the cell entry as 2. Next when we compare GTCA with GXT, we have to take the maximum of this one and this 2, so we get 2. Similarly for GTCAB and GXT, we get 2. Next we move on to the next row. So we have the entry X here. So when we compare GXTX with G, they are not matching, the last characters are not matching, this is X and this is G, so we have to take the maximum of 0 and 1, so we get 1. Next we compare GT with GXTX. X and T don't match, so we take the maximum of 1 and 2, so we get 2. When we compare GTC with GXTX, C and X don't match, hence maximum of 2 and 2, we get 2. Similarly for GTCA with GXTX, the maximum of 2 and 2, we get 2. For the next character also, that is GTCAB and GXTX, again we have to take the maximum of 2 and 2 as X and B don't match, so we get 2. When we move on to the next row, that is GXTXA, when compared with G, we have to take the maximum of 0 and 1 as A and G don't match here, so maximum of 1 and 0, we get 1. When we compare GT with GXTXA, again we have to take the maximum of 1 and 2, that is 2. Next we compare GTC with GXTXA, so the characters A and C don't match, so we take the maximum of 2 and 2, that is 2. Next we compare GXTXA with GTCA. Here the class characters, that is A and A, are matching, hence we have to use this logic, that is take the incremental of the upper left diagonal element, 2, that is 2 plus 1, we get the cell entry as 3. Next we compare GTCAB with GXTXA, so this cell entry is the maximum of 2 and 3 as the last characters A and B are not matching, so we get the cell entry as 3. We move on to the last row of this matrix. So now we compare GXTXAB with G, the last characters don't match, so we have to take the maximum of upper adjacent row and the left adjacent column, so 0 and 1, we get 1. When we compare GT with GXTXAB, we have to take the maximum of 2 and 1, again we get 2. Now when we compare GTC with GXTXAB, the last character don't match, so we again take maximum of 2 and 2, so we get 2. Hence is the case with GTCA and GXTXAB, the last character don't match, so we take maximum of 3 and 2, we get 3. When we compare the whole of first string and whole of second string to get the last entry of the matrix, we see that the last entry is matching, so we take the incremental of the upper left diagonal element, so we get 4 here. So this 4 is the length of the longest common subsequence between these two strings, that is GTCAB and GXTXAB. So how do we find the actual longest common subsequence between these two strings? For that we have to traverse from the bottom right corner of this matrix to the top left corner of this matrix. Let's see how we find the longest common subsequence. So now we consider the last entry of this matrix, that is 4. Where did this 4 come from? We check the respective column and the respective row character of 4, both are equal, B and B. So using this logic, we know that this 4 has come from the upper left diagonal element, that is 3. So when we move diagonally here, we have to note down the respective column character, since this will be included in the longest common subsequence. So we note down the column character, that is B. Next, we check from where did this 3 come from. When we compare the row and column of this particular cell entry, both are equal, A and A. So we have to traverse diagonally upwards. So we have to also note down the particular column character, that is A. Next, we check from where did this 2 come from. When we compare the column, that is C, and row X, they don't match. Hence, it will be the maximum of this 2 here and this 2. So hence, we travel horizontally here to the next column. So we don't need to note down this C in the longest common subsequence, since there is no diagonal traversion here. So next we compare the row and column of this particular 2 here. The column character is T and the row character is X. Hence, we can't move diagonally here. So this 2 has come from the maximum of this 1 here and this 2. Maximum of 1 and 2, as we all know, is 2. So hence we move upwards. This 2 has come from this entry here. So we move vertically upwards. Next we have to check from where did this 2 come from. So we have to compare this T with the respective row. Here the character is T. Both are equal. Hence this 2 has come from the diagonal element, upper diagonal element. So we have to note down the particular character, that is T. It will be included in the longest common subsequence. Next, this 1. When we check the row of 1, it is X and the column is G. Both are not equal. So we can't traverse diagonally. It is a maximum of this 0 and this 1 here. So we have to move vertically upwards, since this 1 has come from this 1 here. So next we have to compare the row and column of this particular entry here, that is 1. Since both the characters are equal, that is G and G, this 1 has come from the upper left diagonal element, that is 0, according to this logic. So we have to note down this particular character here, that is G. Since we have moved from the bottom right entry of this matrix to the top left of this matrix, the obtained result is in the reverse order. So to get the final actual longest common subsequence, we have to reverse this particular obtained result. So the actual longest common subsequence between the given two strings, that is GTCAB and GXTXAB, will be GTAB. I hope you all understood the logic behind the working of dynamic programming in finding the longest common subsequence. I have written a full article on this topic at FreeCodeCamp, which I will be adding in the description of this video as soon as it is published. So thank you once again for watching this video.